Welcome again for the ones that were here still like 1 hour ago, I guess. So myself again here. I would like to talk today about the immersion integrated OCP racks. Before we were having a bit of a summary about what the community has been doing for OpenRack version 3 in immersion. But Submer as a company has been actually doing quite a lot into this push back in then, and I want to go through the initial summary now. So the question is, why Submer has been interested into doing that much with OCP as of today. So basically, OCP had the immersion-born community, and that is bringing a lot of value to all of us, speaking about fluid, speaking about regulations, and now, of course, moreover, about the OpenRack specifications, right? So we started back in then with the OpenRack version 2. We integrated many of those tanks in the market, working as of today in production with all of the benefits that they have for us. One of the most important benefits, for example, having 800 millimeter tanks that are feasible for everything, with all of the servers working in a unique size and a unique shape. Then we have, of course, the way that we don't need to rely on a lot of PDUs and cables when we need to look at immersion tanks. That is making the operation of them very easy. And then, of course, we have all of the advantages of having the power supplies all in one side, so they are easy to replace, or they are very easy to just combine with different vendors that are doing ORv3 power supplies. So this is the summary. You can see in the screen, of course, all of the company contributions that we have done since the very beginning. There is, of course, the FMEA that Amy was mentioning before. There is all of the power distribution that we are leading in our work stream. But then there is, of course, other things that we have doing about the safe handling guidelines. And now we have Roma in our company as well about the cleaning guidelines as well. That is very important for everything that we immerse in an immersion tank. So I want to go through all of you about what we have been doing to be here and have this product properly qualified. This is actually the qualification process that we need to follow. It's called Immersion Requirements. It's a very extensive Excel that actually speaks about all of the elements that you need to comply with. Maybe for immersion tanks is temperatures, flow rates, weight, sizes, everything that is important. This is an example here of what we have been doing already in 2021 for the OpenRack version 2, and that we have today published into the marketplace of OCP. And now I'm going to go through all the details that we have been doing the same now, but for, of course, the OpenRack version 3, which is the one in the market as of today. So this is just a snapshot of a bit of the general standards that we are considering as of now. As you can see, there is a lot of the elements that are, as I was saying, considering pressures, rates, kilograms, weight, sorry. One of the important things is in the data centers, greenfield data centers, no, but brownfield, they are existing data centers that they integrated air racks in the past, but now there is a lot of weight that our immersion tanks are having. So the kilos per meter square is a very important rule, for example. So you need to decide if you use a technical floor or concrete floor, things like that. So all of these are a lot of the requirements that we have been going through. ASHRAE has been also a very good referent for this. For example, the water quality requirements for a data center, what you need to consider for that. Submer has learned a lot. At the very beginning, we even had galvanic corrosion in our tanks on the connectors, just because we were not considering to use different or same materials, same metals when we were using the connector, so that was affecting it. So a lot of learnings have been going through about the general definitions for tanks in immersion, and OCP has been a very good backbone for it. About quality and safety, we have, again, similar stuff. Some of that are already appeared into the previous session because it's related to the ORv3, of course. So the busbar preventing the short circuits or the weight relying into it. We have, of course, other things like the management of it, so how an ORv3 power shelf or a server can be safely installed into the tanks, following lateral guidelines or rails that are making sure that the server and the power shelf is not moving forwards and backwards. So all of these are the elements that you will find through if you go through the qualification Excel, the qualification requirement, to make sure that your tank can be also ORv3 and you can deliver a full solution. There is a very good part that is actually led by the the work stream of hardware management, sorry, it's the DCIM, how I can monitor my immersion tank into the data center, how I can connect with it, how I can use different protocols to monitor all what is going on, alarms, alerts. So in our case, we have the Smart DC platform, is the software for our tank, and it actually can connect with SNMP, an API RESTful API, sorry, and also SMTP email alerts, of course. But this is making very easy to integrate with your data center, so you can understand and create alerts about different temperatures for the fluid, pressures, any alerts about the pump that stopped working. So you can have complete control of what the immersion requirements, what your immersion tank, sorry, is delivering to you. About the busbar now, going into more detail, something we have tackled before, we have determined that, of course, a busbar can go in the center of the tank. As I same, it goes in a vertical air rack, but also to increase the density, which is one of the main points of the single-phase immersion tanks, we can also install 3 busbars in one tank. There is already many providers doing power shelves that they have connectors at the bottom that they can switch to 3 different positions, and the same with the servers. So basically, you can have 3 busbar in the bottom of the tank where they are very well cooled, because it's the coolest zone in the bottom of the tank. And then you can connect to each of the busbars, so you can deliver a lot of kilowatts of dissipation. So this is something that we have been also going through and qualifying through the community. It's working as of now. We have production deployments going on with this, and the customers are quite happy. So we think it's another way to increase the density into the immersion tanks. This is the image that you have seen probably before. Rolf made a very good point before about the busbar polarity, another very important point about how we can install the IT hardware and the power shelves into the immersion tanks, so making sure that the positive and the negative is always in the same side. We are not frying any server, we are not making any risk by installing the things improperly. And there is also the lateral stoppers, as we were commenting, to make sure that the weight is never relying into the busbar, but onto the tank structure. So we don't have any busbar with plenty of weight on it, and that actually was not designed for it. If you are actually asking how the busbars are designed for immersion, they are actually mostly the same. I mean, of course, we are going through a material compatibility review about the busbar in case they are using glues, because some of the ORv3 busbars, they are having glue, so we are reviewing if that busbar have a glue that can be diluted in immersion, or that it has any material that is not compatible. But besides that, as long as that, it's just making it for the right size for our tanks, and then we are good to go. There is nothing else that we need to change or over-engineer. The busbars are completely fine in immersion, and as we have saying before, they can deliver a lot more of density than in air. This is also the integration bad now for the power shelf. So basically, you can see here that the power shelf have the AC to DC connector up in the surface, not in the bottom, as most of the power shelves have. So this is one of the major changes that we need to do for immersion, avoiding capillarity and other risks that we can find. So if you can see, of course, in an immersion tank, to have power cables or any sort of cables in the bottom is not very practical or to operate it. So we try that always the connectivity is in the surface of the tank, power, fiber, network copper, all of that. So the power shelves as well, they have the connectivity in the surface. And of course, we have also the placement outlines, the lateral guides, so they cannot move left to right inside. So they are following always straight direction when we are inserting them from top to the bottom. This is actually one of the tests that we have been doing, very important to understand all of this conceptual information that we have that actually is real. So actually, we doubting if we can push more a power shelf in immersion, if it can deliver more, if every power supply actually can deliver more than what it was designed for. So the answer is yes. On the test that you will see now on the next screen, and that Amy was referring before as well for the FMEA community, speaks about the density that we can achieve with this. So actually, down in the left, you can see a picture. This is a lot of heat loads. This is not servers because they are very expensive in case we are frying them or they are failing in the test. So all of those are heat loads that are generating all of this load. So they are 54 kilowatts of heat load. And then there is the power shelf at the left that is delivering those 54 kilowatts. You can see the sensors that we installed into the busbar, into the upper image, to measure the temperature and the amperage on every part of it to make sure that the performance was great. And actually, this is leading us to this image. This is the most important image. Why? Because up in there, you see the temperatures that actually these components are working in air, typically, and then you can find the same correlation of that component in immersion into the worst case scenario. Into the worst case scenario, I'm saying this because the tank was brought into the highest temperature that we can operate it safely with our customers, which at the moment is 55 Celsius set point. And it was in the worst temperature with a maximum load that you can deliver. And what we have seen that, for example, if I'm trying to find a value, so D111 says that in air works at 175. And if I'm finding here in immersion, it says, I cannot find D111 now. Well, I can find another one, I guess. So for example, Q102, it's 150, and we have 69 in immersion. So less than half of it. In the worst case scenario, the component is very, very well cooled. So we can push power supplies that can deliver more kilowatts in less space, very efficiently in immersion, and very safely. There is no risk of sparks. There is no risk of fires. These are other tests that we have done just later on, like switching on the cooling, switching off, switching off the cooling, switching off also the power, see if the temperature was increasing, see if there was anything that was making a risk in immersion. But no, it was not the case. Everything was very safe. So this is an image that gathers all of I've been saying at the moment. So it's basically showing how the integration of Upper and Rack version 3 in an immersion, single-phase immersion tank can be. So you can see represented by colors, but you can see the compute nodes that we can have as servers into an immersion tank. Then you have all of the power shelf and the PSUs inside that. And then, of course, you can have all of the switches or that can be inside on the tank already. We have already some switch vendors and providers that are doing the switches for immersion. But if they are not dense enough or they are not providing a lot of heat, we can have them outside and not waste that space for it. So this is our integration. It works very fine today. So just to jump in the conclusion, we believe that single-phase immersion cooling can deliver a more efficient and sustainable environment for Open Rack standards. We have been doing it for Open Rack version 2. We're doing it now for Open Rack version 3. We hope for the version 4 if it comes at some point. But the good thing of this is that all of these load tests are proving that the conceptual idea of having this in immersion and having more efficiency, it's actually happening. Here you have, for example, in this conclusion, another example of the busbars that we have today. So we can see already here busbars that are using more copper, HPR busbars. They are very big to just cool down the heat that they are generating. So we don't know if actually this can scale further. We cannot keep solving always the higher electricity or more heat, just adding more copper and making the things bigger. We can also maybe not fix it putting water next to the busbars. At some point, maybe it can create a risk. So the good thing of this is that we don't need to over-engineer anything rather than just installing it in immersion, that the tank takes care of the entire cooling for all of the components. And as Rolf was saying at the beginning of today, into the opening session, we can do precision cooling if required to the specific components that needs it, like GPUs, CPUs, but still the rest of the tank, everything is cooled, and it's in a very well-cooled environment. In the left, sorry, just to close up, you have a graphic that shows as well the connector that actually our teams from Molex there, they have in their booth, that also demonstrates that even we are increasing the amps that they need to deliver. The graph keeps it very low, so the temperature rise in immersion is actually not a lot. So everything is, again, very well cooled, and we believe it can be the future for everyone. So in the call to action, this is something we are working I've been explaining here. We did it at Submer, but we have a power distribution in immersion workstream where everyone is participating, sharing ideas, how we can keep improving ORv3 in immersion. So if you are interested, you can please join. You can share any feedback that you want, and of course collaborate into the spec document that we are working at the moment. So with this, thank you for your time, and if there is any questions, I think the time is up, but you can probably find me out the door there. I will go there.